Is it audible to you now? Okay, na? Thank you.
సెకండ్ ప్రమాణ స్వీకారానికి 2019లో డైరెక్ట్ విపక్ష నేతగా
అది ఓపెన్ చేయండి సార్. ఆ లాస్ట్ అర్థం కాలేదు సార్. దేని
Good afternoon, Naga Srinivas, sir.
Good afternoon, sir.
Okay, shall we start the program, sir?
Yeah, sure, sir.
Okay. Thank you, sir.
Yeah.
Just I will start.
Good afternoon, sir.
Good afternoon, sir.
I'm Hussein.
Yeah.
Okay. Baunara?
Yeah, one, sir.
Okay,
Yeah.
right.
So, how is going program, sir?
Yeah, good, sir.
Yeah, fine.
Good afternoon to one and all. A warm welcome to second day of this online 1 week faculty development program on advancements in construction materials and practices. Now I take a privilege to welcome today's speaker, respected Sri G. Naga Srinivas, sir. He is going to take a session on IoT enabled system for water purification and generation. So before start the session, I request Mrs. K. Hemalata Madam, Assistant Professor, Civil Engineering, to introduce the speaker. All the very best to all of you and happy learning.
Thank you, sir. It's my privilege to introduce the speaker of the session, G. Naga Srinivas garu. G. Naga Srinivas garu is currently working as Principal Scientist in CE and PT Division, CSIR, Hyderabad. He is an innovative IT professional with overall 24 years of leading research institute expertise in CSIR data center to spearhead technological integration to optimize the operations of servers, high-speed networks, HPC clusters through understanding of switching architecture, implementation on wired and wireless networks, software and hardware-based firewalls, surveillance networks, multimedia, video conferencing, SS control, and network security. He is strong in Windows operating systems, open source customization, virtualization technologies, directory servers, web portals or servers, databases, storage networks. He is having vast experience and knowledge of data center design and maintenance, acquaintance of communication protocols and routing protocols. He is very familiar in spanning tree protocols, ability to create a loop-free topology for institute networks, specializing in supporting popular network brand architectures with technical competency in supporting switching, routing, load balancing, endpoint protection, etc. Regarding his education, he completed his Master of Computer Applications from Andhra University in 1997 and his PhD from AKNU University. He has completed many certification courses, mainly on Microsoft and Cisco Certified Professional, MCSE and CCNB. Thank you, sir. Thank you for accepting our invitation. I would like to now call G. Naga Srinivas garu to please proceed with the session.
Yeah, thank you, madam. Thank you, sir, for giving this opportunity. Just I'm starting now. Just tell me after sharing the screen whether it is my slides are visible to you or not.
Yes, sir.
Yeah. Is it visible?
No, sir.
Yeah, just.
Yes, sir. Now it is visible.
Yeah.
Please keep it in slideshow mode, sir. Yes, sir.
Yes,
It is clear. Thank you, sir.
Yeah. Yeah, good afternoon, everybody. Actually, my background is more IT background. Recently, now we are doing most of the things are on IoT, AI. You might have heard artificial intelligence, machine learning, and IoT, Internet of Things. So now actually IICT is many domains or R&D domains are there. So now we have started with the water domain. So this water domain, we have applied this IoT technologies. So in this lecture, I'm mainly focusing on IoT based enabled systems for water purifications. And then I will come to the atmospheric water generations. Then at the end of the session, we can ask any questions. Yeah, actually, this is the process. Any IoT, if you want to implement in any domain, don't think that it is restricted to the single domain, water domain, or any domain. Now we will take any generic domain, we can apply IoT. If you take a general domestic purpose, now IoT is using in home automation and all, they are using rigorously. 80 to 90% they are scaling up, and they are implementing home automations. Whereas in other domains also we can implement actually. So these are the process and design operations we have implemented IoT. Basic division is that generally if you take in water domain also, several kind of different kind of waters will be there that for specific applications. So one application, if you take atmospheric water generators, then parameters will be different. Whereas if you take in metal grade water also, some specifications, water parameters will be different. So based on the water, we can take automation of the, we can do the automation of the particular plant, and we can take the parameters online. So those parameters through the sensors, it will sense the data actually. Now, if you take the data, it will be the sensor. Now, if you see here, the smart connected devices will be here, and ThinkSpeak is the cloud domain actually. Then MATLAB will be the for analytics. I will tell you like this. The first step will be the sensor. So sensor will sense the data. Let's assume I will put a sensor in atmospheric water generator, water supplied by the CWG. So then it will sense the most crucial important parameters like TDS and pH like that, and flow also, flow rate also. Now once it sense the sensor will sense the data, then it will take the analog signals and it will convert into the digital. In coming up slide, I will show you that architecture also. Then it will send to the cloud. This ThinkSpeak is called as a cloud database. So that sensor data will push through the Wi-Fi or 4G communicator. It will send to the ThinkSpeak. So then from ThinkSpeak, you can get the web-enabled system. Either through MATLAB Analytics, after MATLAB Analytics, you can see in your desktop system, which is connected to internet, or you can see through your mobile app also. So in this, generally what we will use in IoT basic components are, generally this is called Arduino. Many open source platforms are came to build work on IoT. So major things are Arduino we are using here. IDE software, use it to write code, and then we will upload to that electronic boards will be there, Arduino boards. Then that boards will connect it to the sensor. So in that code itself, Arduino board itself, we will write the code to send the data to the cloud also. So sensor will just sense the data and give it to the Arduino. So Arduino will process the data and it will connect to the cloud. From the cloud, we can see the value of that particular TDS. In general, what will be the deliverables will be generally preventive maintenance and remote monitoring and troubleshooting. Generally, remote monitoring is, it helps a lot because of once you do automation, this kind of water plants, because generally water plants will be, it will be in the top of the building. Either if you take any multiple floors or 20, 38 floors, going top of the floor, top of the water tank, top of the floor, and collect the sample water from the tank. And if you see that traditional way, taking the probe and checking the TDS quality of the parameters, it's a tedious job, right? So that means even you can do 1 or 2 times like that. So multiple times you cannot do. So but if you do this automation sort of thing, then you can get 24/7 mode kind of thing. You can see the data and more accurately also. So that is the advantage of, so no human intervention will not be there in this IoT task. So I hope this will be the major architecture for everything, any sensor, not only this thing. You can come like a soil sensor, or TDS or flow, any sensor. This will be the major architecture behind the sensor. Yeah, this will be the feed tank will be here. Then process will be there through water treatment plants will be there. So after that feed tank, then here in outline of the tank, filtered water tank, or we can say permit. In permit line, we can put the TDS and flow sensors. So the sensors will sense the data, descends to the Wi-Fi communicator. So here in heavy water and big water plants, generally 1,000 liter per day and 2,000 liter per day, and very big water plants, generally this architecture they will use. That means Wi-Fi communicator will be there. So this Wi-Fi communicator will be here it will be, you can use two types of communicators here. If Wi-Fi is available, you can use Wi-Fi. In remote locations, sometimes you will not get any Wi-Fi, like if you in agriculture fields and all. There you can use GSM based Wi-Fi communicator. So from this communicator, we can sense the data, so that data can be what will be the TDS and flow. According to that, they will do. Here I am showing you the slide of this IICT hospital, where we have developed medical grade water system. In that medical grade water system, doctors can see the TDS level and flow. According to that, they can plan how many kidney dialysis patient they can do per day. So if TDS is there, then it will be the indicator for them before doing this pre-check for the kidney dialysis. So like that they will plan. So according to the flow is also very important. According to the flow only, they can see that it will be accommodated for how many patients, like that. So this will be the sensor will be here, like TDS sensor is here, and where we will incorporate here TDS sensor, and this will be the flow sensor, and these flow and TDS sensor will be integrated to this Wi-Fi communicator. Okay, this is base architecture for any water plants, bigger water plants. Yeah, this we are implemented at two places. One at ISIC. I think you have seen it. ESI hospital is there at near Midpet. There, and another is Nilofer Children Hospital. So these two plants we have enabled both TDS and flow sensors. So through mobile we can get the values. See, this is the TDS value in PPA in 1.35. So flow rate also 775 liter per hour. So total consumption before that, 2 minutes before, what is the consumption? And this is the total consumption, how much you have. So you can see the date, and you can see the date and the last sync when it is happened. So this type of things you can see in online. And this way, you can see the backlog history of each parameter also. If I click flow rate again, if I click on this flow rate button, right side you can see the flow rate per hour. In every minute it will show you. Every 1 minute or 2 minutes it will show you the almost history of the particular flow rate. Okay, so like this we can see the online automation for the plants for the IoT. Yeah, this is earlier what we showed is that is for water plants. This is for atmospheric water generators. I will come across later that atmosphere, what is AWZ. I will show some slides also. But before that, what IoT part I am covering first, because if what is the IoT part in AWZ. So that here Arduino board, as I said earlier, this is called Arduino board here. Then this sensor will be there, DHT11 and DHT, this white one is 22 and blue one is DHT11. So by using this Arduino board, we can connect it to this sensor, and this sensor will sense the data and sends to the cloud. So from the cloud, you can see the parameter, you can see here 28.7 and 70.90 is the humidity, 28.7 is the temperature. So the same thing we can get in our mobile app also. This is also developed for our MSL. So through this app, we can get the values from the cloud. Whatever values are there, we can retrieve the values, same values through the app, mobile app. So this advanced water generator, this sensor will continuously sense the humidity and temperature These two factors are very important for the AWG because for this temperature and humidity, they will calculate dew point. Based on the dew point in the arid and hill regions, they will see they will estimate the water quantity and further running of the plant. Because sometimes in hill stations, it will be condensed also to the snow and all. So that dew point calculations, so the engine will stop automatically. So this online this one sensing, online sensing and quantification. So this, if you take this gas sensors also will take as the same scenario. So either SO2 like H2S, CO2, CO, many different, each and every gas there will be a separate sensor will be there. So these are all gases will be sensed by the sensor, and through the VLAN gateway it will sense to the internet, and that cloud server will be there, and it will post into the cloud servers. From cloud servers we will use from the cloud devices. So this will be the routine. From cloud it will through internet it will fetch the data. Two-way communication is there always here. So from internet it will go to the cloud server. From cloud server it will fetch, and again the client device will come to here, and from client device to internet is already connected. So this will be the board will be like this. You take MQT sensor, try here actually, sensing the data with the UNO board. Then the architecture will be the above the architecture. Generally, in future, IoT is not the independent component. If you see the right side, so there will be many components are there. Sorry. That is integrated with IoT. So the connectivity part, main IoT, 4G they are using right now because of IoT. Whereas if you go for IIoT, then 5G is there. You can able to use that 5G. 5G you can use. So that in 5G is the main very faster speed, and it will be very low latency also, and it will coverage broader coverage also due to their spectrum. And it will use a OFDM method also for modulating the digital signals actually. So, and also interference also will be it will be very low in the channels. So this will be the main 5G will be the major communication for this IoT. Almost all now we are all using 5G right now. So IoT is one of the main component integrated with, because without 4G or 5G, there will not be communication. We cannot do any automation. So this is very, very crucial. Either you use 4G or 5G. Then coming to the cloud, then there's another part is that the second important part is cloud. So through that media, then where it has to post, the data should be posted into the cloud computing. So this is also major resources. The storing the data or managing or analyzing the data we can use, because it will keep on post every 2 minutes or every 3 minutes. So that data, if you see 1 year, so you can get 365 days into 365 days into 24/7 more. So you will get huge data for any parameter. So through this cloud computing, you can see the analyzing the data and storing. And for IoT, another is we have to see the cyber security also. And it's not that IoT project in the sense you have to take care of all the 4 components. So nowadays, now they are insisting more on security, cyber security. So can devices in network applications and data from digital attacks also we have to see. So IoT will be secured by defending devices also. So common categories like endpoint security, you can use the cloud security or network security, application security data. And that means if you are designing any IoT model, then automatically all components will come. So for each and every component, that means starting from your desktop to end. So whether all cyber security policies, whether we are following or not, is a major task in this. Then AI, of course, AI is also main. These are all subsets only. AI, artificial intelligence, machine learning, and IoT. These are all subset to each other. So each way it may, when you are designing or when we are developing a model, so you may come across any, either machine learning may required or AI also may required. So by helping with real-time data analysis and decision making also. So sensor, if you connected sensors, IoT sensor devices, provide time real-time data feeds to ML algorithms. So by using this ML algorithm, it will digest the data and it will analyze and it will interpret and send instructions back to the device. And let's assume, suppose I can say in medical grade water, TDS is the 10 ppm. In that case, suppose ppm is cross 10 or 15, then you simply stop the plant. So like that, I will send back instructions also by using this. And these are the components it's required very much in this IoT designs. Yeah, and coming to the, I covered as earlier AI also. Now the machine learning where it will be useful in gassing area also. Using machine learning tools like DL algorithm to be developed for CO2 separations from industrial off gases. So from we can how it will be, we can differentiate CO2 from the industrial off gases. So literature will be there for the data input instead of sensors. And research methodology with development of AI-based regression models for predictive model. So CO separation from water gas shift reactions and you can these are the deliverables for the these are the deliverables for the ML by using the machine learning algorithms. Okay, so same thing. See, whether earlier we have used the sensors and parameters, we can do preventive maintenance. Whereas if you come to the gasification, so if data is more, then you can do the some predictive modeling by using the machine learning. Okay. So just as an example, I've given CO2. That's all. Yeah, the same thing now we have not only the water domain. Recently, we have come across this agriculture field also. We have developed one soil testing sensor for the agriculture field. So this soil sensor will test the kind percentage of moisture in the soil, any agriculture soil. So if you keep that sensor, then it will continuously sense the data and it will sense to the cloud or again to the mobile app or web enabled interfaces. So there also you can use the either Arduino, you have used Arduino boards for here. And this is also for preventive maintenance, remote monitoring, troubleshooting, because we cannot go for every time to the agriculture fields and test the soil. This will be the real-time data you can get from the agriculture field. So based on the soil moisture, they can go for some other test. It will be useful for further test for the agriculture scientist. Yeah, this we have designed this. This is the soil sensor, and this we have concealed mode, and inside circuit will be there. I will show you that in next slide. Yeah, this will be the soil sensor. And inside this box, this will be the Arduino board will be there, and some GSM module will be here. And GSM module will be here, and this we are trying to integrate with the solar panel, because each and every project some challenges will be there. Suppose if you see in agriculture field, then you will not have Wi-Fi and power also. If you put in a remote places. Okay, whereas in water plants, I am easily getting Wi-Fi and power. That's not a problem because it is in hospitals or every within the cities, not an issue. But whereas in agriculture fields, solar and power and Wi-Fi is a big question there. So we are trying to give the solar panel power to this particular design so that it will continuously, even cloudy based environments also, the solar power will generate the power, and anyway it requires 5 volts only, so that within the battery will be connected to the solar panel. From the battery, it will comes to this circuit, and the GSM based SIM will be here in top of this GSM module. Yeah, apart from IoT is going on for, of course, it's going spreading into multiple domains and multiple fields. Now, in IoT, there is another advanced technology is IIoT. So just I stands for industrial only. So industrial IoT, Internet of Things only. So delivers real-time water treatment monitoring, allowing customer to visualize water performance issues at the enterprise level. See that's the difference. It is in IoT we can do some enterprise level. That means at a time we can club hundreds of plants together. So in IoT you can see the sensors will be very limited, whereas in IoT unlimited sensors we can deploy. So that's the major difference. So whenever the more sensors are there, number of sites will increase. So automatically you can see the enterprise site and asset level also to help achieve sustainability, productivity, and profitability. So these are the three goals we can achieve through the IoT. And cloud computing we can say. So IoT cloud computing, which that means IoT also will have same features of IoT. Basic other components like cloud computing, AI, and ML. So in future, IoT and cloud computing will be shaped by AI and of course ML, as I mentioned earlier. So that means AI can analyze the data and predict the outcomes and make decisions, making it essentials to boosting IoT system. Whereas if you come to the ML base, so it will recognizes the pattern in a big data from sensors and IoT devices. So suppose the same pattern is there. Let's assume if I'm getting any water parameter since 15 to 20 days, then what will be the next step? What will be the decision? So ML will gives the pattern recognition, and then AI will take the decision. So that will be the same thing as earlier discussed in cloud computing. So if you say impact of other IoT, on some industries IoT. So electricity industry is there. In electricity, they are using the plant automation, checking of the condition and equipment, and maintenance of sustainability environments. And if you are taking transport domain, real-time management of orders and shipments, automated vehicle tracking, and another is on-demand inventory management. So like gas and oil, measurement of crude oil extraction ratios, connected oil and gas pipelines, and remote asset monitoring and management. And hospital, if you take room automation, the like temperature and other factors also they may use. Improvements in room services, integration between resorts. And water, of course, water flow controllers, as we did already, flow controls and all. And wastewater treatment is another domain in water, and smart consumption management. So this will be in use in a bigger way in coming the future. This comes under as IoT. Yeah, till this we have used. I have explained about the IoT part only. Now IoT enabled systems and the water generation is also there in our lecture. So from here onwards, I am focusing more on atmospheric water generators. So generally, in many places, groundwater is not available in many places in India, particularly hill stations and arid regions. So as a IICT concerned, we have executed one project for this water scarcity. One designed called atmospheric water generator system. So that for this system, there is a ground level it will not be linked with the groundwater level. So it will take the water from the humidity. So from arid regions and hill stations, this will be very useful. So wherever groundwater is not available, so that mineralized water you will get it from these systems. So 5 locations we have implemented this: Latur, Vachi, and Machilipatnam, and Darjeeling. So these places we have implemented. So this AWG features, atmospheric water generator features, are silent features are captures atmospheric humidity to produce clean water. And another is humidity. Even if it is in some other regions, humidity levels is 25% low. Also, it operates efficiently, this unit. So this capacity will be 1,000 liters per day. So different capacities is also available. So it produces a remineralizer water having TDS around 100 ppm, 100 to 150 ppm. So it's through dosing of a proprietary salt mixture solution. This proprietary salt mixture solution is prepared by this IICT. So this is the patented one, and it is combinedly Maitri Aquatech and IICT. Both are this is joint patented for this product. And indigenation of technology and indigenation of technology by introduction of the renewable energy. Of course, this is an renewable energy resources, that is fine. And atmospheric water generator exhibits strong potential coastal regions. As I said earlier, the arid regions and hilly regions, it is very useful. And Chennai and all, wherever humidity is very high, so this will helps a lot actually. So that means Machilipatnam and sea areas, wherever sea areas are there. So ICT is signed MOU with Maitri Aquatech. So indigenous core component, remineralization and post-treatment of the water. And overall, they have cleared 50 installations till date in India and abroad. So the dosing remineralization has taken care by IICT. So these are the air filters will be there, air intake, the from air, it sucks the air from the environment. Then outside evaporator will be there, and water will be collected here. And then inside evaporator will be there. And due to these fans, then it will be, go through the this external condensers and compressors, and this will be the exhaust air. So then this is a generic architecture of this AWZ. So this is the just flow of the flow chart of this part. And this one air is drawn through the air filters will be there. Air will be sucked. See, if you see the top of this is the AWZ unit. This is the AWZ unit. I think Dr. Hussain has seen this when he visited IICT. So then it will moisture, it will capture some moisture from the air, and then the condensed water collects in a tank. Then next process will be condensed water in a tank. Then in between, for to kill the other bacterial ozoonation will be done. Then collected water is filtered and remineralized and passed through the UV. So here remineralization and UV will be at last we can put after the collecting the water and ozoonation. Then we can get the pure mineralized drinking water. So this will be there. So Dr. Sridhar is our MSL group chief. He has produced this technology for remineralization technique. And for this IAWG, we have done the IoT part also. Yeah, in Secunderabad station and Bombay railway stations also we have used. You can see Meghdut water from here. So this is the outlet we have created at railway station there. Then here we used at Latur. As I said, 5 locations we have installed this water generators, and this is the one of the reason. It is Uttarakhand, and if you see cascaded applications for RO generation. Automobile industry, you can use caustic soda and power plant boilers. Medical grade, actually if you see medical grade water, it will use for saline solutions and dialysis fluids. And for biotechnology environment, you can use for microbial cultures. And colleges and schools for lab grade water also. This is for medical grade water generation. So from RO, how it will be filtered as this one. This is the architecture and this is this one. So process of demineralization of water using membrane integrated ion exchange resin adsorption columns. These are all internally water architecture of this plant. Yeah, system for ultra pure water for medical and both biotech applications. See, that depends on the application. This will be designed. This water filters and membranes will be designed for biotech applications will be separate and medical applications separate. Medical grade water will be separate. Alkaline water is separate. So if you see for this advantages is this one and highly compatible and 40 to 60 liter per day. And this is actually, if you see international brand, if you see milliQ, it costs 50 to 15 lakh, 5 to 15 lakhs for this. And whereas if you see, this is the advantages of 80,000 only is internally deployed this water. So 5 paisa per liter for this, 3 times capacity compared to that one. So they have done some 7 successful installation within IICT. We have inside campus and each and other outside the campus sniper UK hospitals CCCR JNT. So like that, there will not be not required much maintenance also. So deployed this technology transfer to these are the other industries they have transferred this technology. Yeah. So if you see this one automated cascade medical grade water pilot plant for dialysis, this whatever earlier I have shown, that is for bigger plants like ESS and Nilofer. Whereas we can use, we can medical grade water also, we can do some cascaded thing, automated cascaded for pilot plants and dialysis also. So this product water will be 500, scale will be there. So then this is the cost and selling price will be there. So this particularly they are useful for dialyzing fluid successfully used for treating. Of course, 1 lakh dialysis patients in NephroPlus. They have implemented this at Kamareddy, Nanjal and Maredipalli branches and 100 patients per day. What I have implemented at ESIC that is the bigger one where this will be the small capacities. Okay. So recent medical graphs, you can see the difference here. I think that is what anyway here it is already mentioned. So by 500 liter per hour is a small grade, and because it is movable also portable, we can take to any location. Whereas here this is a bigger plant is 500 liter per hour. So already 2 million liter of water already they have used, and this is IoT enabled. You can see in web enabled systems. This is the plant of the SIC. Thank you. And I will show you one before that. I will show you one video also regarding this. Please see that. After that, you can see the questions.
Hello, sir. Your video is not coming, sir. Hello, sir. Hmm. Hmm. Sir, your video is not coming. Hello, Naga Srinivas sir.
ఫోన్ చేయండి సార్.
శ్రీనివాస్ గారు ఫోన్ చేయండి సార్ పర్సనల్ గా.
I called him, sir, but he's not lifting phone. Just what happened? Let us inquire. Hello, Naga Srinivas sir.
Hello.
Hello, sir. Your video is not yet started, sir.
Oh, okay. It's just, anything stuck, sir? Just I'll reply again.
You stop this sharing, sir. Then you share that video.
Yeah, okay. So can I take questions, sir, now, or any questions, sir? So I will share the video later.
Questions, sir. Dear participants, please ask your questions. Please unmute yourself and ask your questions. I think there are a few questions, sir, in chat box.
Yeah, I will reply it, sir. No problem.
One question is there, sir. Can we predict the pollutants in sewers, sir?
Yeah, sure, sir. In that will come under the wastewater treatment plant. So that from that wastewater treatment plant, we can see some pollutants, sir, actually. So that is possible, sir. That will be, of course, we are not yet started, maybe that, but maybe go in next year. That
Okay.
wastewater
One more
treatment
question is there,
sir.
sir, from GVV Satyanarayan, sir. Can we install the IoT system in chimneys to identify the impurities present from industries as the temperature of flue gases are very high?
Yeah. Yeah, maybe that I think right now it is started. Maybe it may be possible. That depends on the gas sensors or anything they're deployed with IoT, because anyway our fridges and almost all TVs almost all they're automated with Wi-Fi itself. So that I think for chimneys also they can go ahead, sir. No problem.
Yes, sir. I have one question. I'm Hussein.
Yeah. Yeah, sir.
So actually, you have checked only TDS sensor and only two sensors you have done, or for all other characteristics you have installed sensors?
Yeah. Yes,
Only.
sir. These two are the most important for the medical grade, sir. That's why I have chosen. But whereas you can see for other sensors deployed DO oxygen levels, if you take prawn culture and all, DO will be the main content for the prawns oxygen level in the water. So that depends on the application. Sensors will differ, sir. If you if you take pH also we can take actually. So as of these are the two primary parameters we have taken that, sir. But you can many parameters are there.
So actually,
Turbidity is also there, sir.
maximum how many sensors can be employed, sir? Maximum. Any maximum limit?
For which thing, sir? Which domain, sir?
to understand the chemical quality
Yeah,
of the water. So there are
yeah,
many characteristics. How many maximum up to what maximum number of sensors that can be installed?
yeah.
Is there any limit for that or?
Yeah, no, no, sir, not all are not required, because if you say that TDS is the main, sir, because if TDS is between 500 below, happily it is drinkable, sir. If it is 1000 above, then it is the hazardous. Actually, it's not, then that means heavy metal solids will be there. So that below 500, TDS is better, sir. That's all. TDS is fine, sir. Nothing, sir. If a drinkable water, if a TDS probe is there with us, that is sufficient, sir. Of course, TDS probe we have to see manually. That's all.
For example, some water fluorine also will be there. Fluorine sensor, fluoride sensor.
Yeah.
We can keep no
Here,
fluoride.
sensor based fluoride level, it's not much, sir, actually. I think in Nalgonda they have treated with filters and membranes only. You need to treat more actually, but the quantification we can sense with that fluorine, sir. I think.
So actually, that the um, ICRISAT people, so they are actually going to villages for wastewater ponds,
Yeah.
wastewater treatment ponds.
Okay.
So they are going on a very high scale to villages also.
Okay.
So can we install here for even wastewater treatment
Yeah.
ponds?
Sure, sir. You can install it wastewater.
Okay. Okay, sir. Definitely, we will work together
Yeah, sure,
for
sir.
our student projects also. We'll involve you, sir.
Yeah, sure, sir.
We look forward.
Yeah, welcome, sir. Most welcome, sir.
Okay.
Yeah, thanks.
Any other questions, please? Dear participants, please unmute yourself and ask the questions. Sir, please go ahead with your video, sir.
Yeah, sir. I will try. Just a minute.
Ah.
Is it visible, sir?
No, sir.
I tell.
Just you screen share, sir. Have you shared your PPTs like that? You
Yeah, I will do again screen sharing in stop screen share and I will do it.
పేరు ఈ లింగారెడ్డి ఎక్స్పాన్షన్ మా పాఠశాలలో ఈ విద్యాసంవత్సర వారాంతంలో అట్మాస్ఫియర్ వాటర్ జనరేటర్ మేలని సరే అయితే దీనికి మూలం ఏంటంటే ఎక్కువ శాతం
Sir, have you shared this entire screen?
ఇటువంటి నీటిని తయారు చేసి
Now it is.
Yeah, I'm starting. Yeah.
Yes, sir. Now it is come.
పేరు ఈ లింగారెడ్డి ఎక్స్పాన్షన్ మా పాఠశాలలో ఈ విద్యార్థి వచ్చిన వారాంతంలో అట్మాస్ఫియర్ వాటర్ జనరేటర్ మ్యాచ్ అని విచారించారు. అయితే దీనికి మూలం ఏంటంటే మా విలేజ్ లో ఎక్కువ శాతం తల్లిదండ్రులు కిడ్నీ పేషెంట్ గా బాధపడుతుంది. అయితే ఇటువంటి విచారం చేయడం వల్ల మా పిల్లలకు చాలా సంతోషంగా తల్లిదండ్రులు కూడా చాలా సంతోషంగా ఈ నీళ్లు తాగడం వల్ల పిల్లలకు ఆరోగ్యంగా ఉంటుంది. ఇటువంటి ప్రాజెక్ట్ విషయాన్ని ఐఐటి హైదరాబాద్ ప్రొవైడ్ మా పాఠశాల ప్రొవైడ్ చేసినందుకు ఐఐటి డైరెక్టర్ గారికి మరియు చీఫ్ సైంటిస్ట్ డాక్టర్ శ్రీధర్ గారికి మా స్కూల్ మేనేజ్మెంట్ గారికి మరియు విద్యార్థులు తల్లిదండ్రుల తరఫున వారికి దగ్గర
CSIR, the संस्था आपल्याकडे आलेली आहे. बरंच ही मशीन ग्रामीण भागात पुरवल्यामुळे आजच्या चांगला फायदा झालेला आहे. कारण ग्रामीण भागातील मुले हे शुद्ध पाणी सफिक नाही, परंतु या पाण्यामुळे मुले शुद्ध पाणी पित आहेत आणि रोगराईपासून जाण्याचा जास्तीत जास्त प्रयत्न होत आहे. तर या मशीन दिल्याबद्दल आम्ही जिल्हा परिषद प्राथमिक शाळा आणि धन्यवाद.
शाळेची पाण्याची समस्या आहे. ही समस्या 100% सुटली आहे. प्रत्येक विद्यार्थ्यांना या ठिकाणी जलसुख पाणी पिण्यास मिळत आहे. त्यामुळे रोगराई किंवा इतर ज्या काही आपल्याच्या समस्या आहेत त्या सर्व समस्या सुटण्यास या मदत मिळत आहे. धन्यवाद.
और पानी भरने वाला जो है तो उसमें बहुत बढ़िया शुद्ध पानी आता है. वो मशीन आने से हमारे गाँव में टीचर छोटे बच्चे में का गाँव मशीन का माहौल बना हुआ और सभी लोग पूछे हम उनका धन्यवाद करते हैं. धन्यवाद आए.
Yeah, completed, sir.
Sir,
So these
what is
are where we
what is the
install
price
LED.
of that machine, sir?
Sir,
Price of that machine, how much, sir? 500 liters per day, that capacity.
it will be 2.5 lakhs, sir. That depends on the capacity.
Okay.
So 2.5 lakh to 3.5 lakhs, sir.
So minimum size of the machine, what is the minimum size, sir?
What, sir?
Minimum size of that machine.
Minimum?
Size that
Size, sir. Mini is also now we are developing actually. So generally, if you say 500, it is starting, sir. 500
Okay.
and 100 also there.
So these machines are not being implemented in residence, just for schools and college only you are implementing, sir, now?
No, sir. Actually, wherever arid regions are there, that means very humidity is high, and at the same time, ground level water is not available. So there only we are implementing, sir. It is not like that wherever groundwater level is available, then not required, sir. You can do it to some mineralization plant or something, generally arbor plant and all.
Okay.
Sufficient.
Okay. Dear participants, any more questions?
Yes, sir. Sir, actually, Srinivas garu.
Yeah.
Sir, Chapani.
So actually, this Uddanam, Srikakulam district. So there are many kidney cases are there. So have you not have you seen that this every time Mr. Pavan Kalyan and also others they talk about Uddanam. Okay. Have you installed, sir, anything there in Srikakulam?
No, sir. Actually, they have to approach us. Actually, since it is a central government organization, so they approach generally for that. I think maybe medical grade water will be useful for them. Hopefully for kidney dialysis patients. If they start the technology, we can transfer the technology, sir. That's not a problem.
Oh, that means they have to pay money?
Yeah, that
Or
plant installation and all they have to pay, sir.
Acha.
Yeah.
So everything other is free.
Yeah, maintenance and all they can see. Actually, we will give that training and all for them.
The cost of that 2.5 lakhs government will it bear?
Yeah, for this is the government DST project. They have provided the fund for all the 5 places. For this new technology. But that's what any sponsor will be there, or that any agency has to come to for the technology so that we can implement that.
Okay. Okay, sir. Thank you.
Maybe this society will be helpful. Yeah.
Yes, sir. Thank you. So thank you, sir, for your ready acceptance.
Thank you. Yeah.
In spite of
any more questions, please? Other participants? Okay, let us conclude otherwise. Thank you very much, sir. You explained very well about architecture of sensors and how IoT is connected to artificial intelligence, cloud computing, and cyber security, the impact of IoT on industries. So actually, we don't know the depth of knowledge related to the software being core branches. Okay. Thank you very much, sir. Even though you are very busy, you spend your valuable time.
Yeah.
Thank you very much, sir.
See you, sir. Thank you.
Okay. Dear participants, tomorrow we'll have session on road safety awareness program by Sri N. Sivat Kumar sir, Senior Road Safety Auditor. Please kindly join at 2:15 p.m. tomorrow. Thank you all.